and a lot of my colleagues will attest to it. We have something, a concept of alarm fatigue. What alarm fatigue is, all the bedside monitor alarms that are built in, they are designed to be sensitive, all for good reason. You want to pick up each and every significant event that is happening. But in doing so, they have made it to be so sensitive that oftentimes there are false alarm. Depending upon which study you read, they say some of these alarms are as high as 90% of the alarms that we deal in the ICU are false alarm. And you can imagine being a bedside nurse who have 20 different medications to give, so many orders to follow. There will be a time when on top of that, if you have to go and tend to each and every alarm, all we end up going is going and muting or silencing the alarm without really paying the attention that oftentimes is needed. So the alarm fatigue is pretty significant, and it contributes not only to the clinical burnout, just another thing to go out and another thing to take care of, but it can be dangerous. It can definitely lead to some inaction when the action was needed. So whenever I've embarked upon this journey, I was always mindful, I don't want to add more to the problem. How can we come up with a creative solution, where we create an arrhythmia detector that not only is sensitive, but also specific. So the different part, or the unique aspect of this approach is we're not using the traditional EKG waveform only for detection of arrhythmias. And this is where majority of the bedside arrhythmia alarms are. They are operating on the EKG. Don't take me wrong, EKG still remains the gold standard, but we wanted to, there are definitely nuances to the EKG as well, depending upon how the leads are placed, depending upon the patient movement. So our goal is to avoid alarm fatigue that happens. So we come up with something that is important and something that is actionable as well. So whenever the clinicians are responding to it, they know they are dealing with something significant.